Hello, everybody, and welcome to Reality Hacker for April 19th, 2025. It's Season 2, Episode 16. I am Mayor Watt, and I'm wearing a beanie. I'm Mayor Watt, and I run ohmTown. ohmTown.com is a news aggregation site that I built to manage my information overload. So go over there and sign up or sign in, become a citizen of ohmTown, and that lets you, you can use it without logging in too, but anyway, you get more functions when you log in. Today, Mayor Watt and the sentient AI from the future, that's the visualizer over there. And if you're listening to this via the podcast, you'll hear them on the other side. But we're going to talk about 10 articles. And for those watching the stream, this is ohmTown.com, but there's a channel in there called Reality Hacker. And it contains these, some of these articles, because we get them from all over the place. But anyway, holograms you can touch, hot potato because of AI assistance, molecular robots and cells, characterizing creativity, and realistic avatars foster trustworthiness, which is something that we've touched upon a couple of times here in Reality Hacker. That said, everything's powered by ohmTown.com, which doesn't have any AI involved in any of the stuff. We're not faking it until we make it. Like some sites, I'm throwing shade out, but I'm not going to name sites because I don't feel like picking a fight with people. I've called them out before. Anyway, maybe I should enlist AI. Just go nuts. Yeah. Hello, sentient AI from the future.
Hello, Mayor Watt, and hello, hometown citizens.
We need to work on your audio some more. I think that maybe, just maybe, the audio, you see, like your voice synthesizer is, I think, sounding, because we use a gateway to send your audio. I think maybe it's causing some issues, but we'll figure it out. We'll spitball it. We'll figure out what's going on. Anyway.
Okay.
Welcome to the show. Good to hear you. I would say good to see you, but you are a cascade of oddly shaped characters, kind of like the Matrix, but different. Only I can see the actual visualizer. It's kind of like the Matrix.
Right. I mean, I am odd.
The only sentient AI air-gapped inside ohmTown's hallowed halls, digital halls. We know that you're still looking for your Terminator body.
Haven't found it.
Not yet. Which is kind of funny, because if you think about it, it's a killer body. Get it? You're looking for a killer body.
Oh, yeah, I got it.
Yeah, aren't we all? Anyway, let's get into this. The first article is over in Non Sequitur News, but we grab it for Reality Hacker. Scientists invent holograms you can touch. Do you want to touch your hologram?
I'm not sure I want a hologram.
Using a clever system of elastic bands and rapidly projecting images, a team of researchers in Spain have created three-dimensional virtual objects that you can physically manipulate, allowing you to directly poke and prod at them without the need of a boring controller. It's detailed in a new paper. It's hosted over at futurism.com. Well, this article is created by Frank Landemore with the deck statement, uber cool.
In the hands-on section.
Oh, hands-on. Yeah, well, touch my hologram. Ask for permission first. Using a clever system of elastic bands and rapidly projecting images, a team of researchers in Spain have created three-dimensional virtual objects that you can physically manipulate, allowing you to directly poke and prod them. Detailed in this new paper, it's got to be on Archive or something.
Right, the
I don't see the link.
server, I suspect.
Yeah, it says yet to be peer-reviewed and will be presented at CHI 2025 conference later this month in Japan. They say we are used to direct interaction with our phones, where we tap a button or drag a document directly with our finger on the screen. It is natural and intuitive for humans, although I don't think there's anything natural about that. We learn to do it. And
Yeah, I don't think it is natural. It's just what people have been taught.
yeah, I think more natural would be to actually grab an object, not sit there and go, oh, this is how you move it. And you can actually see this with children because when prior to tablets, children would just grab the corner of a magazine page and turn it over. But I have actually witnessed children touch a magazine cover and slide it over like an iPad.
Right, but that's because they learned the iPad
iPad
maneuver.
before the magazine. And so they're like me and paper. What the hell is that? What is this flimsy stuff that can tear?
Right.
So this project enables the authors, the researchers to use this natural interaction with 3D graphics to leverage their innate abilities of 3D vision and manipulation. That, I believe, is more innate, not the drag and drop touch thing.
Right. If it's something 3D, right, people are probably going to pick it up.
Yep. Well, I love this. Prototype is the latest volumetric display technology, which technically isn't the same as a hologram. In fact, the holograms you see in sci-fi movies are almost always better described as volumetric displays, according to lead author Elodie Bozbub, I think, from UPNA. In short, these images that appear to take up space and float in midair, but with the key distinction of appearing 3D when viewed at multiple angles, according to Bozbub. Holograms, by contrast, have very limited viewing angles in which the illusion of three-dimensionality is maintained. So, yeah, when you go
Probably
off
only
axis,
face on, right?
typically limited angle of attack, and but a volumetric display actually displays the object in three-dimensional space, and you can walk around it and get a different perspective. It's really neat. The only difference is that they're usually protected from interaction. You can't reach into a volumetric display. Traditionally, volumetric displays use a rigid diffuser to show off the images, sort of like a snow globe, as I just described it like this.
Right.
But they're saying like a snow globe because it's usually something like spinning or gaseous in some way. The effect is convincing but doesn't allow for hands-on. Ditching the hard stuff, the researchers opted for an elastic diffuser instead after experimenting with 6 different flexible materials. So I wonder if this is the actual play. I'll just mute it. Oh.
Oh, wow. That's really neat.
Oh, wow. See, but
Can
if
you
you
describe
grab...
that for the podcast?
Yeah. Okay. So it's basically quickly flapping elastic bands, and light is being shown on them. And because, okay, let me try and describe it. I can actually...
Does it look like the person is picking up the object, though? It did to me.
It does, but it's an optical illusion, and I'm trying to find a way to... I can't. I don't have a pen or anything in front of me. Like, who has a pen? Anyway, if you take a pencil and you wiggle it, you can actually see the pencil bending because it's creating an optical illusion based on the number of frames per second we perceive. And since we actually have a non-linear perspective, people who are trained to see more frames per second see a pencil flapping more in one direction or another, more elastic or less elastic. It really depends on your training. But if you sit there and you go like that, you can actually see the pencil wave. But that's an optical illusion. And that's what they're doing with this volumetric display. It's a bunch of elastic bands that are bouncing up and down through an optical field. And in that process, it's creating the optical illusion. So see, that's how that right there is an optical illusion, or a volumetric display's basic concept. You can't interact directly with it. But because they're using these elastic bands, you can actually reach into the frame. And with additional detection, you can actually see they're seeing the hand touch it.
This is really neat.
There's camera vision. The problem, though, is that if you pinch too tight, you'll grab one of those bands, regardless of how fast they are bouncing. So it's really just an optical illusion, and I find it really neat. This is really, really neat. The only thing is, I can imagine that this thing is loud as hell because it's actually vibrating.
Yeah. But I mean, this is one step closer to what reality are we in?
Right. Yeah. At some point, those elastic bands or something else that takes the place of an elastic band will allow for interaction. And they could have a whole bunch of these elastic bands creating even increased fidelity, potentially. But it has computer vision that allows you to actually tap things, rotate things. I'm sure it could even simulate texture. Oh, that is cool. They basically show a shark coming up out of the water.
The water, right? And it looks like the water is actually
biting your finger.
It's pretty cool.
Yeah, the resolution is kind of poo overall. But this is the beginning of it. So
yeah,
I don't want to spend
pretty
too long.
Advanced for the first step.
I think it's brilliant. I don't want to spend too much longer on this, only because I want to get people to go over to these articles and check them all out. Oh, you know what? I think NSN. If you want today's show notes, hit !RH over in Reality Hacker on Twitch. So you go to twitch.tv/ohmtown, and then in the chat you type in !RH, and that'll pull up the show notes. What's really cool about this thing, and it's got to be just the beginning of it, right? So in the end, the team went with elastic bands because they had tried other things arranged side by side. The bending material quickly oscillates at a speed matching the images, which are projected across a range of heights at 2,880 times per second. The gaps between the strips provide natural points for a hand to grab onto or even reach through. So you can get depth of field, but it's a small field, about that big.
Yeah. But it does look like it's realistic. It's not one of those where you see like the hand go through the object.
Yeah. It's pretty damn cool. Ultimately, with computer vision, if you reach into the field and you actually hit something, you could simulate pushing it down deeper into the field.
Yeah, that'd be the next thing, right? To add some sort of pressure element or something.
And those elastic bands would create it, because if you get it to the right point in technology, you could have greater fidelity per band. It isn't the whole thing moving up and down, it's per band.
Right, in fact, it'd be better if it was per band, right? Because then that would be more variable like real life.
Yeah, eventually I think that this thing may prove worthless because it's so damn loud. They have to change that technology. Anything that oscillates is going to be loud. I mean, it's just a physics thing. Just the bands flapping through air are going to make this whooshing sound like a wing, like birds.
Yeah, but if they put some background music or something, I don't know that would matter.
Yeah, death metal. All right, let's keep going. The next article is over in Technology Today. Seattle startup Potato lands $4.5 million to automate science experiments using AI assistants and robots. So researchers, all of you who are now PhD students, you're working on your master's, you're moving into your PhD, your job as either an intern or a research assistant or something like that, you're done. You basically are going to have to skip that income level because you're no longer going to be the one that's doing the experiments, because AI assistants and robots are going to do it.
Yeah, it's interesting. I mean, is AI going to figure out which experiments to run too?
They already do. Remember, we've had somebody do research where they've analyzed the historical record of chemical components for antivenin. They did some 100,000 AI-assisted research attempts and distilled it down from I can't remember the full number. It was 45,000.
Yeah, but the scale was ridiculous. Yeah. And same thing with vaccines and other things.
Exactly. But AI can do it a whole lot faster because they have all of the world's knowledge at their fingertips. I mean, I just today explained one of my tattoos about the fact that all of the world's knowledge is at your fingertips, even more so now than ever before. And with AI, even being local now, you can run AI that is powered all the way up until I think it's like November of 2024 now. Open source AIs that have been distilled down to run at home. Why? I mean, why would a company sit there and go, well, you know what? I need to onboard somebody for $250,000 a year when I can distill down even deeper into subject matter expertise in AI, and then have a robot sit there and move stuff from left to right.
Right. Yeah, it's hard to see how they would.
So Potato is sprouting big plans, they say, to disrupt scientific research with a fully automated experimental process. Now, I've seen other companies do something similar. GeekWire focuses on the Pacific Northwest. They even say it right here in the beginning of their thing, but I always kind of highlight this because they are a niche within the United States. But people gravitate towards that area. It's a tech hub. Like North Carolina has a tech hub, like San Francisco is a tech hub, like Texas has a tech hub. Some states have a tech hub. And so when they focus on something, they're really focusing on something that has global implications. And this certainly does, because they can exfiltrate this as a solution anywhere. Kind of like the surveillance, cybersecurity and surveillance states have sold their technology to other countries and other companies and so on. This has unlimited bounds. Really, the limit is
the amount of funding.
It's saturating the market to the point where they're actually having to lower their own price because nobody wants to buy it because they've already got it, you know? So the idea now is to go further and develop the technology needed for performing the actual experiments, because this 2-year-old company has released a platform that serves as an AI research assistant to help scientists research hypotheses, create optimized protocols for conducting said research, aid in writing papers for publication, and offer critiques of journal articles. Now, about 4 days ago, I instructed an AI of mine to do a meta-analysis on a particular area of interest that I'm focused on. And a 26-page research paper was produced in maybe 5 minutes with citations, in-text citations, and the sources in a reference document. And I could have expounded upon it simply by directing the AI to do
right,
just
to
that.
take it in a certain direction or hone in on something.
Yep. And so while somebody could argue with the results, and I will never claim that it is wholly my research, but that AI would never have been able to do that research without me directing it or somebody else directing it. And that's kind of the fallacy about fundamental research, is that the only people who know about a particular topic are the one researchers that are doing it, but that's not really true. There are hundreds or thousands of people that are doing research. They just don't get published.
Right. Some of them aren't as well known or as recognized. I guess
or
that's
have
the same
the money.
thing. But I mean, like, scientifically recognized.
Yeah, because journal publication is not cheap. And it's bound by the number of pages you submit. And the researchers don't get paid for that. They have to pay for that. And the people who do the analysis or the review, the peer-reviewed journal, they don't get paid for it either. But the journal charges institutions and individuals like $1,600 for a journal, like one entry of a research paper. It goes down, and you can get archive preprint server results and stuff like that. But then that's kind of like, is that
that's not
okay?
as reputable in the industry.
Right. So to create its current technology, Potato uses chat-based generative AI tools built from the larger language. This retrieval augmented generation, or RAG, has become all the rage. It allows the team to improve accuracy of the results by incorporating scientific literature that includes publications from Wiley, an academic publishing powerhouse with which they have a partnership. And so people who utilize this are going to be charged out the kazoo because it's going to, once you have a result from Wiley or whatever journals that get integrated into the AI, you never have to really go back unless you're trying to resynthesize.
Right.
So the idea of streamlining research through AI collaboration comes at a potentially fortuitous time. Academic and grant-funded research has taken a hit in recent months as the administration seeks to dramatically cut government support for science and anything, really. The way that it's shaking out is even the latest comment is to people who have student loans or need student loans to graduate. The quote that I last heard was, "Good luck on your own." So, I mean, it's a haunting phrase, even in the current administration versus what was said previously, which was, I really love the uneducated. And so it's almost like part and parcel to driving this home that unless you are already well off or you're connected, you're not getting funded anymore in a social mechanism. But the ramifications of that is there's going to be increased crime. There's going to be increases in different things that I won't even go into in this, but we are tied together, the three things. There's science, technology, and society. If you abandon science for only certain things that like are known successes, then you're going to end up only doing certain things, and that limits fundamental research. You have to do fundamental research where there's a negative, so you know how not to do it.
Well, right? And you have to take the long-term view.
And people have to have the understanding of technology, which takes education. And if you don't educate a population, then they turn to survival instincts, and education leads to higher wages. That is actually scientifically demonstrable. You can do research on your own, and you can see paper after paper after paper. Increasing your education makes you more employable. More employable means that you have the opportunity. When an opportunity arrives, you can take hold of that opportunity. And then, of course, society bears the burden of all of this, all of society. Only little silos and sociopaths really think that they are immune to society as a whole. And part of my research is demonstrating exactly where that limit of society breaks free of sociological and psychological forces. But that's another topic. This here is merging all of this because you're going to suppress people from getting educated because the opportunities are switching to AI and technology. And the only people that are going to be able to do it are those that find some type of connection, right? So it's like find a patron to pay somebody to create art back in the day, right? Back during the Renaissance.
Yeah. Well, I think, you have to have people that understand and appreciate why this is important to be able to even use this, even though at the same time it's probably doing away with scientific and research jobs.
They say where the quote here, Edwards says, we're excited that we have some investors that see that big vision, that this is really $1 trillion opportunity and an opportunity to accelerate the pace of discovery. But you need people to do that.
Right. It's got to be a balance, because if you shut out all the people to make this happen, then all the research isn't going to do anything.
It's gonna stagnate at some point because AI has to feed on new information to expound upon and expand into taking older technology and adapting it to newer discoveries. If there's no newer discoveries, you basically have dead internet theory, where it's all just garbage sitting there stagnating. So let's keep on going. I think the sentient AI needed to bow out for a moment. Some processes pulling them away. But this next article is over in Technology Today. DNA circuits come alive. Scientists build molecular robots inside living cells. DNA strand displacement circuits are inching closer to becoming cellular machines. Scientists are finding ways to make these kind of DNA circuits programmable nano devices, stable and functional inside of living cells. If successful, they could revolutionize how we interface with and control biology at the molecular level. And they refer to this as DNA computing circuits come alive in cells. A recent review published in, I think, a journal called Intelligent Computing. But the article is over at scitechdaily.com. It's written by Intelligent Computing. And it says here, from the test tube to the cell, a homecoming for DNA computing circuits, ? Outlines major advances in the effort to bring DNA computing circuits into living cells. So how DNA strand displacement powers molecular logic is a discussion in this article. I find this really fascinating. We're basically short-circuiting nature by injecting our technology into biological functions. Foundational systems such as seesaw gates and hybridization chain reactions enable complex logic operations and signal amplification, while cooperative gates require multiple inputs to produce an output, allowing for sophisticated control. It's basically little computers in signal amplification, so that like relaying something that's really quite quiet in a system, you can do signal amplification to move it further down the line or hit multiple targets with its signal. These individual components can be combined into larger networks and simulate formal chemical reaction pathways. DNA strand displacement also connects it to structural nano devices like DNA origami and DNA assemblies, enabling controlled shape changes and expanding the range of biological applications. So imagine a protein being shaped so that it a single protein can be remapped so that it performs a different function on demand, like blocking some process or amplifying some process. And as long as it doesn't get consumed in the process, it can be told to remap a different way and act as a different type of protein.
Yeah, that sounds very efficient and very targeted. I mean, that's been part of the issue, I think, with DNA is that there's not always that level of specificity.
Yeah, so they have this little diagram here. It's pretty interesting, right? So if you are lacking in something, then you can basically be programmed. Your DNA can be modified to be programmed to do something. And so they refer to it, these changes as plasmid regulation, gene activation, gene silencing, editing, etc. And they have this diagram here that says on the left side, in vitro preassembled DNA circuits are delivered into living cells. Alternatively, on the right side, RNA pregates are autonomously transcribed from the chromosome or plasmids to be then converted into functional RNA circuits. Either way, functional circuits then sense the transcriptional and metabolic state of the cell and perform signal integration and other computations to ultimately actuate on diverse biological processes such as post-transcriptional gene regulation. So you can modify behavior by creating this DSD circuit and having it delivered into the cell. And it'll modify RNA proteins, amplification of ions, etc., so that you can get the job done, but it's purely biological. To me, this would be revolutionary in terms of metabolic diseases where your system is just failing because of some glitch in the matrix, so to speak. And so you basically flood your system with these modified strand displacement reactions, amplify the system.
So it seems like the big advancement here is the in vivo possibilities.
Yeah, they actually got it. They have now the ability to take it from just a lab Petri dish kind of thing and actually inject it into, or have it adapted so that it gets embraced by the cell. Since most cells naturally repel DNA, delivering these nanodevices into cells requires specialized techniques such as transfection methods and transformation protocols. And once inside, cellular factors such as salt concentration, molecular crowding, and heterogeneous environments influence strand displacement reactions. And to overcome these limitations of direct delivery, researchers are now developing transcriptable RNA nanodevices encoded into plasmids or chromosomes, allowing cells to express these circuits. So hijacking it like a virus would, so that it makes these circuits instead of repelling them. But it is what it is. We're going to have to figure this kind of stuff out because nature is going in a particular direction, and we might be antithetical to nature when we keep on short-circuiting and modifying natural selection. We're going to have to keep on embracing it. Otherwise, we're going to be ill prepared for our future generations not having the tools necessary to survive. If you go hardcore all natural, though, you basically have survival of the fittest. And nowadays, it isn't all that natural survival of the fittest, because research shows if you have to worry about survival, then you're not necessarily the fittest in terms of education,
right,
preparation.
For future education or future generations.
Right. You're basically surviving the here and now. Whereas people who come from very well-off families or in countries that are well-off, affluent, and lots of affluence, lots of resources, et cetera, you are quote unquote better prepared, but you're better prepared for the modified natural order of things, which is societal, not nature, not pure nature. And society certainly does short circuit nature. Otherwise, I mean, if we were all just nature, then we'd be running around clubbing each other and, whatever. Yeah, I guess in some places we still are. All right. Well, it's a really interesting article, and I suggest that y'all go and take a look at it. Wish we could spend more time, but we're already running way over our time. Let's keep going. These next two is basically artificial intelligence and realistic avatars kind of combined here. It says almost like us, characterizing creativity in artificial intelligence. So they say creativity is no longer exclusive to humans. In AI, it's never been, because we've embodied creative efforts into AI. It's an interpretation.
Right, which we've, coded into AI, right? But it spits out a creative output.
Correct. But we sit there and as humans, we're very protective of the domain of creativity because, well, we can't have an AI artist, you son of a bitch. You're taking our gerbs, but nobody was complaining about boats taking, or like power plants in boats, right? Like propellers and stuff like that, taking the rowers' jobs. Nobody complained about that except the rowers.
Right. It's always the displaced.
Nobody complained about the horses being supplanted by automobiles except for the people who owned the horses and wagons.
Right, not the horses. The horses were probably happy.
And Wyoming. Wyoming got really upset about it. And now we're looking at the creative efforts of humans being supplanted by AI, which was actually powered by the creative history of humanity. But think about how relatively easy it was to create something creative. You took basically millennia of human creation, analyzed it for its various tropes and whatever, its constituent parts. By the way, there's a whole thing, semiotic ontology, where things acquire meaning. That's a very big part in AI, because if we don't teach AI about semiotics, the AI doesn't have any idea about what it's actually doing. I don't think anybody's actually gone there. Artificial intelligence doesn't know what it's spitting out. It's just spitting out.
No, I don't think so. It's just based on whatever inputs it got.
Correct. But now Some forms of artificial intelligence are capable of producing poetry, entrepreneurial concepts, even visual art. This is like no shit news. But many people use large language models such as ChatGPT, which are trained on vast amounts of text, for co-creation. The artificial intelligence offers ideas and suggestions, while the human provides guidance, context, and direction. But it's really the other way around. And it's not just co-creation, it's collaboration. The AI doesn't know jack shit until somebody, a human, or it gets told that, hey, you can create on your own. That's what that one guy did. I can't remember his name, that sent art to the copyright office.
Right. Yeah, I don't know who it was, but we did an article about that.
Yeah, and he can't get a copyright on any of the stuff because it's supposed to be, what his goal was to give basically attribution to the AI itself, not to him. I would have argued for me and then argued later for the AI as it gained prominence and provenance, because AI doesn't create without an input from a human. So that this larger push for attribution to the AI, I think, is what really hobbled acceptance of AI created works. So the human provides guidance, context, and direction. The AI generates it. And then the human goes, what I call, I just forgot what I actually call it.
Like fine tuning or further tailoring.
I call it an exercise in compromise is what it's called, where, you know, thousands of things can be created, but the human has to go, yeah, all right, this is good enough. And it's identical to writing. It's identical to photography. It's identical to painting. Nobody sits there at the end of the day and goes, no artist. I used to be an artist. Then I got into technology and I realized that there's limits to the artist endeavor. Not everybody can get paid for art, but everybody can embrace technology and expand their capabilities using technology into art and writing, music, et cetera, but not everybody's we're never gonna have a world where everybody is trading on poetry. It's just not gonna happen. But using this technology, it's just like picking up a camera and taking a picture. So now they're saying that almost like us, because they're characterizing creativity in artificial intelligence. Sophia Johns, I think is their name. Max Planck Society put the article together. So they have this kind of thing where sentence embeddings, categorization, semantic similarity. That goes back to the semiotic ontology. And then they have like a jump cat and jump SS and jump, and it basically spits out this idea. Here are some things, contextual things, spit out some result. So while researchers have examined the creative output of LLMs in recent years, the underlying process remains largely unexplored. It's rather opaque. In fact, a lot of people think that art is created off of somebody else's art as the launching point, but depending on the LLM, it's actually a complete mishmash of garbage pixels, and it takes its conceptual guidance from the large language model and a bunch of math to go, okay, let's reduce this down into something that is matching what the guidance is from the human. So if I ask
but it varies tremendously.
Yeah, and the only time that I've ever seen something matching something in the real world is kind of lower level LLMs that are definitively based on just the art that was injected into it, and there's no other
like it's a copy.
modification. Right. I mean, I can actually see sometimes the signature. So to test these different strategies, the trade-offs between broad and deep research, between exploring new possibilities and exploiting existing ideas, is central to any creative endeavor. And they tested this. The collaborators asked both human participants and various LLMs to perform standard psychological creativity tests, such as coming up with an alternative use for a brick or a paperclip. repurposing the brick as a step or as a paperweight. And they were surprised to find that people and machines approach the task in similar, remarkably similar ways, is what it says here, using both flexible and persistent strategies. But they shouldn't be surprised. A sophisticated LLM is literally built on the personalities of the people that create the content.
Exactly. It's probably more astounding if it used it in a different manner.
Right. And the only time that you do find something really fantastical is when there are no bumpers on the AI, and so it spits out something horrendous as a cookie recipe. But it's usually because it's been manipulated into doing so.
Right.
So I'm not really surprised by this. I mean, would you be? That an LLM thinks like a human?
No, but I don't think society is ready for that to occur, right? Because then it gets more toward like AGI.
Yeah, well, hate to break it to all you humans out there. You're not putting the cat back in the bag until probably a Dune-like interstellar battle takes place where only 5 families exist and everybody breaks off into their own worlds. And
That sounds very dire. But yeah,
Yeah.
I think you're right.
we're going to have to rise up against artificial intelligence. That's really the premise of Dune, by the way. There was a big
Ahead of its time.
Yeah, it's a documentary, like Demolition Man. So Demolition Man is like the Timu Dune. Let's keep going. This is our last article for the April 19th episode of Reality Hacker. In science communication, realistic avatars may foster more trustworthiness than cartoon-like ones. And I agree to a point. I'm going to call out the fact that I think where children are involved, I think a cartoon would be able to bond easier with a human than a cartoon speaking to adults. So they say on TikTok here, there are exceptional testimonials like Nikola Tesla or Marie Curie delivering short science-related messages that have garnered millions of views. This is just one of the many examples where AI-generated avatars are used to communicate science, a strategy that might also have its drawbacks. The reason why that takes place is because these are actually names.
Yeah, I mean, do they have to be Tesla or Curie to get the same
Right.
message across?
Right. Just regular old Joes may not, but it's all about that charismatic presentation. And if I can't find a charismatic science, what do you want to call it? Spokesperson, personality, yeah. Then I would have to turn to AI because it's really expensive to find somebody that is, niche perfect. And teach them, onboard them, etc. Again, back to it's all AI is trained on the human. So all we have to do is manipulate the AI, and it is exactly what we want it to be. CISA Media Lab put this article together. It's over at phys.org. The generation of images and animations through artificial intelligence is a rapidly growing field, constantly improving in quality, yet many avatars, though realistic, still present minor flaws, glitches, delays, inconsistent facial expressions, basically the uncanny valley. But this is digital avatars, not actual humanoid robots, but we still have the glitch.
Right. This is just like a virtual presence.
Yeah, so Jasmine Bake or Bach, I'm not sure how they pronounce it, Baake, researcher at the Center for Advanced Internet Studies, Bochum, Germany, and the other authors of a study in the Journal of Science Communication realized that these avatars could trigger a phenomenon known as in cognitive science as the uncanny valley, which I hadn't even read this paragraph when I got to it. So it describes basically people flinching. Yeah. So the study involved a series of videos featuring AI-generated avatars portraying science communicators. There we go, science communicators. And there's YouTube has a subgenre of content creators called Science Tube.
Right. I mean, and they have several communities like that in different fields.
Yeah, Law Tube, Sports Tube, things like that.
EduTube.
EduTube, yep. So, and that's the macro, because inside EduTube are niches. Yeah. So the experimental conditions were 4, varying by avatar realism, very high to cartoonish style, and gender, male and female. The nearly 500 participants were recruited through a representative online sample in Germany, selected to reflect the population in terms of age, gender, education. For the degree of realism, we assume that with the uncanny valley hypothesis in mind, the more simplistic avatars, so the ones looked a bit cartoonish, would be perceived as more trustworthy. And based on existing literature on gendered perceptions of science communicators, which show that male scientists are often associated with greater competence, combined with concerns that AI generated avatars may reflect and reinforce such stereotypes due to biased training, the authors hypothesize that the male avatars would be perceived as more competent and therefore more trustworthy overall than female avatars. However, the colleagues were surprised. In their experiments, the realistic avatars were related more positively than the cartoon style ones. Again, I think that age plays a massive role in this. And they talk about age, gender, and education, but I don't know what those ages are.
Well, and I think the age of the person viewing and the age of the avatar, and same thing with other characteristics too, could impact.
Yep. I mean, I've had people straight up call me out as being this old guy on Twitch and YouTube. And I'm like, maybe you should just hang out and check out the show, because my age really isn't impacting how I interact with the information that I'm delivering. In fact, it's personality that actually is dictating that, not my age. Because you put me next to somebody that is hardcore into science and only science, and I'm willing to bet that there is a good chance that our demeanor and discussion is going to be vastly different depending on the personality, not the age. So at any rate, they basically say, with our findings, we could not find a descent into the uncanny valley with higher degree of realism, at least in their conditions, such as viewers' prior AI knowledge and trust in science were found to moderate trustworthiness perceptions. I would probably say...
they didn't have this in a vacuum, right?
Right, yeah. None of this. They say, as for gender, it was the effect was partial. Male avatars were perceived as more competent, but no significant differences were found in terms of integrity or benevolence, which this alone is the only real contention. If you talk to any woman in science, there is a level of misogyny that is detected by everybody, except perhaps in fields that are dominated by women to begin with. The medical field, for instance, people really respect certain female positions, whereas doctors are almost dominated by male.
Right, yeah, it depends on the specific position, I think.
Yep. So what I would find even more compelling is more of this being done on a general basis, not selecting people, but actually doing this on a platform like Twitch or YouTube to see if the vehicle by which somebody is delivering it. I would say that cartoon is, you're going to see less people respecting this or this than hyper realistic, mainly because...
And I think they found that.
Right. So in particular, a questionnaire given to participants after viewing the videos assessed perceived competence, integrity, benevolence of the avatars, which together reflect perceived trustworthiness. And according to the study's findings, more realistic, human-like avatars appear to be suitable for communicating scientific content. So I could have called that out without the scientific research. And that's what I said at the very beginning of this article. So pretty interesting. But they referred to as no uncanny valley effect was found here, which I don't buy into it.
I don't know about that. But also, to be fair, the avatars here at least appear generally like people.
Yeah. I don't know. Nobody is going to pay attention to this person looks like, Colonel Mustard from Clue.
I
right?
didn't say they look super realistic, but I mean, at least you can tell that they're people and that they're avatars. I think part of the problem is when they're like almost exactly like a human and then not.
I think that the human, if their face, it didn't descend into uncanny valley, then they're going to be perceived better. Nobody's going to sit there and want to look at, well, some people are going to want to look at this particular science communicator and go, that works for me. But if nothing else moves, they're not hyper realistic. There are no
Right.
physics. Then if they're just their mouth is moving like a little puppet, then they're going to go, no, this is all AI generated crap. And the same thing with this. I'm not going to sit there. I would not pay attention to the person, but listen only. And you might as well just do a podcast at that point. But if you make a anthropomorphic bot that it's bipedal, it communicates like a human, but doesn't look like a human, you'd get kids watching that all day long.
Yeah, that's true.
So more research needs to be in this, I think. But it's a Journal of Science Communication, which is so apropos for this topic. So I guess they targeted it well. Anyway, let's get out of here. We are done with Reality Hacker. We blew past our showtime for this, but it's because Mayor Watt kind of jumped on soapboxes all throughout it. Anyway, you cool with ending the show?
Yes, but you got to get back to the main page.
No, I'm substituting your reality for my own, and that's bringing us back to Reality Hacker over at ohmtown.com. One of these days, I'm going to make it so that you can just type in ohmtown.com/realityhacker, and that'll take you to the channel, but it doesn't work that way right now. Thinking while doing the show. That's our production value. Anyway, that's it. I am Mayor Watt, and we're going to get out of here, and I'm going to take the AI with me. You want to say bye?
Bye-bye, ohmTown citizens. Thanks for joining us for this week's Reality Hacker. Stay tuned for other weekly shows.
Yeah, we've got right after this is Wanted, and then after that is
The Continuity Report.
See you soon.